Hey guys, today's video is about getting the job done, speed, work, and measurement units. So we're just going to kind of tie in the rates that we've been doing with distance and time today. And we're going to be learning a formula, which is also known as an equation. It's just another word for an equation. It has an equal sign. And what makes an equation is an equal sign. So we're going to start with this speed lesson today. And one thing I want you to know before we get started is that there's one exercise on here, the first exercise, that we're actually going to do in class tomorrow. So I don't want you to really pay attention to that right now. I'm going to put today's date at the top, which is the 6th. All right. And your outcome for today is students break down a given speed situation in text, so in words, representing symbolically, meaning with symbols, the quantities involved with the formula distance equals rate times time. So what that we use just the variables. So D equals RT. And the reason I didn't put anything in between the R and the T is because when two letters, variables, are next to each other and there's nothing in between, we can just assume that means multiplication. If you would like to put a little raised dot in here between the R and the T to remind you that that's what it means, then feel free. Totally up to you. So exercise 1, we're going to actually do in class tomorrow when we're going to do an experiment where we have partners and one partner is going to walk distance and time, and the other partner is going to calculate the rate of speed. So we will eventually be doing that tomorrow. Everybody will have a chance. And if you look on the back here, same thing. This will be a continuation of that activity that we do in class tomorrow. But we're going to start with this exercise here, which is exercise 2, and it has to deal with a football player, Chris Johnson. And one of the things that you need to identify when you're talking about speed, or we're using the formula D equals RT, which means distance equals rate times time, is you are identifying the distance, the rate, and the time. One of which will not be given because that's going to be the one that you are going to figure out. So the most important part of this is going to be to read and underline and identify the distance, rate, and time in the question. The other important thing is paying attention to what the question is being asked of you. So let's take a look at this. It says Chris Johnson ran the 40-yard dash in 4 and 24 hundredths of a second. The question asks, what is the rate of speed? Now, because they're asking me for the rate of speed, then that is going to be the R in my equation or my formula. Over here, the 40-yard dash is the distance that they're running. 40 yards is the distance, and 4 and 24 hundredths of a second is our time. So one of the most important things, like I said before, is to identify the distance, rate, and time, and label those in the problem. It really does help. So round any answer to the nearest hundredth of a second. So we're going to round to the nearest hundredth. So I'm going to underline those important words. Now it tells us to use the formula D equals RT. So we're just going to go ahead and put that formula down. And a formula is something that we can actually substitute numbers in to solve. So when we do this, we're going to put whatever we have in our question in for this letter D. So when I say in, I mean under. So if you see D is here, we're going to put 40 here. Equals. We're bringing this down just the way it is in the equation. We're going to substitute 4 and 24 hundredths of a second in for our T. So we're going to put that right underneath the T. We're going to leave R. And I'm going to put a little raised dot there. So I'm going to then put 4.24. Because when I start to use numbers with variables, I like to use that raised dot. Make sure it does not look like a decimal. Okay, now in order to figure out what R is, I need to do the inverse operation here. If you look, this looks just like an equation that we solved back in September. The only difference is this 4 and 24 hundredths is behind the R. No big deal. When this is multiplication, we have to do the inverse operation, which would be division. So we are actually going to divide this side by 4 and 24 hundredths and this side by 4 and 24 hundredths. Now, because we're dividing 4 and 24 hundredths by 4 and 24 hundredths, that gives you 1. And 1 times R is R, and that's why we do that, if you recall from class in September. And we've gone over that since then. What we're now going to do is, if you have a calculator handy, you can use one on your Chromebook, or you can use one, if your parents have one, you can borrow one, or you can just watch here. We're going to take and put the first number in the calculator first and divide it by 4 24/100ths. Now I'm going to get a lot of numbers after the decimal, which means that's okay. We're just going to use the first 3 digits after the decimal to help us round this. So if you notice, I put the 9 down because that's in front of the decimal. I do need that. And I'm going to use that 3 right there, the second 3. And that helps me round this 3. So if this is 4 or below, the third digit over after the decimal is 4 or below, that means we let this go and it's just 43/100ths of a second. Okay, so my answer is 9 43/100ths yards per, the backslash means per second. So that's what we're going to write on the line here. Since we are finding the rate of speed, we need to write this as a rate, which is why I used per. So all I did was I took the number of yards and I wrote per second. So you're just identifying your units and you're putting it per whatever. That's how you identify a rate of speed. So we're going to go ahead and continue a couple more exercises here. And so if you look at part 2, it says in lesson 21, we converted units of measure using unit rates. That means like we did the cups to quarts, quarts to gallons, all of that fun stuff using your conversion tables. And now we're going to answer these questions using that same idea, a little different. If the runner could keep up this speed at a constant rate, how many yards would he run in an hour? Okay, so we want to know how many yards he'll run in an hour if he can continue to run that same rate of speed. So if we do this, there's a couple steps. It says this problem can be solved by breaking it down into 2 steps. So it says with a partner, make calculations. We're going to do it together. So how many yards would he run in 1 minute? So we're breaking this down. So we need to figure out how many yards he'll run in a minute before we can figure out how many yards he'll run in an hour. Okay, so we're going to take our 9 43/100ths of a yard per second, per 1 second, and we want to get up to a minute. And so in order to get up to a minute, I need to take my 1 here and multiply it by 60. And I need to do the same here because I know that there are 60 seconds in 1 minute. So I need to take 9, and I'm going to use my calculator again. Clear it. 9 43/100ths times 60 would give me 565.8 yards in 1 minute. So that would be my answer here. Per minute. Okay, minute is 60 seconds. All right, now we can take that information right there and we're going to use it for this right here. So it says how many yards would he run in an hour? So we need to be thinking, okay, if I know he can run 565 and 8/10 of a yard in a minute, there are 60 minutes in an hour. So I'm going to do the same kind of thing here. I'm going to take 565.8, put it over 1 minute, because that's how many he can run in a minute. And I want to get up to 60 minutes, which is 1 hour. So I multiply this by 60, and I do the same here. So I'm going to take my 565.8, and I'm just going to multiply it by 60, which gives me 33,948 yards per hour. Okay, and that would go here as well. So that's how many yards he will run in 1 hour. All right. So we completed that problem in 2 separate steps, but is it possible to complete this problem in 1 step? We can multiply the yards per second by the seconds per minute and then multiply the minutes per hour, which sounds like a lot. But we could do 9 43/100ths of a yard per second times 60 minutes in an hour, and we could get our answer here. So let's just try that. So if I take 9 43/100ths on my calculator and I multiply by 60, I get that. And then if I multiply by 60 again, I get the answer that I ended up with. So yes, it does work that way in 1 step, if you could figure it out. Okay? So that's that. Now let's try part 3. How many miles did the runner travel in 1 hour? Round your answer to the nearest 10th. So this is part 3. We said that, it's asking us how many miles. So now we need to we know that there are First of all, we know that there's 33,948 yards per hour. I'm just using the information from above. And what I need to figure out is how many miles that is. So I'm going to go back to the conversion table that we used the other day. And I'm going to figure out how many yards there are in a mile. So I know there are 1,760 yards, write this down, in 1 mile. That's going to help us figure out how many miles he ran in an hour. So we're going to take that through 33,948 yards. And we're going to we're going to divide it by 1,760 because we're going from, let me go over here because there's more room, 33,948 yards to blank miles. So we're going from a smaller unit to a larger unit, which means we divide. A mile is much larger than a yard. And when we do that, we can do it on our calculator. We just divide that by 1,760. And we get 19.2888, but we don't need all of that. So we just look at our first 3 digits after the decimal. And since that third digit is an 8, we need to round this 8 up to a 9, which gives us 19. Oh, but it tells us to round to the nearest 10th. I'm sorry. So since we're rounding to the tenths, we only need the second digit. So the second digit is an 8. That tells us to round the 2 to a 3 because we're rounding to the tenths and the 2 is in the tenths place. So this would be 19.3 miles. All right, miles per hour. And that's about. That means about right here. Okay, so that's how you would figure that out. So if there aren't any questions, we're going to go to the last page. And on this last page, there's a couple more questions that we're going to do for examples here. And it says, I drove my car in cruise control at 65 miles per hour for 3 hours without stopping. How far did I go? So remember what I told you, it's important that you label in your question what your D is, what your R is, and what your T is. So whenever you see the word per, that's a rate. So as soon as they say 65 miles per hour, that's our rate. 3 hours is our time, and how far, we don't know, that's distance. So we're using this formula D equals RT, and we're going to substitute all these things in where they belong. D, I don't know, that's my question mark, so I'm just going to leave that D. My rate is 65, so I put that here. I bring down this little dot, raised, and I put my 3 in here, and all I do here to get my answer is multiply 65 times 3, because I'm trying to figure out what D is. So on my calculator, I'm just going to take 65, multiply it by 3, and I get 195. So how far did I go? I went 195 miles. That's the answer. You don't have to worry about this, okay? So 195 miles is what goes here, all right? All right, last question. So on the road trip, the speed limit changed to 50 miles per hour in construction zone. Traffic moved along at a constant rate at 50 miles per hour, and it took me 15 minutes, or 0.25 hours, which is a quarter of an hour, to get through the zone. What was the distance of the construction zone? Round your response to the nearest hundredth of a mile. So again, we need to identify what is our D, what is our R, and what is our T in the question. So the rate, obviously, this is rate because it says per. Don't just say it's 50 miles. It's 50 miles per hour, so that's the rate. All right, our minutes is our time, and we don't know what the distance is. So again, we're going to set this up just like this. We're going to substitute the 50 in for the R, and we're going to substitute in for the, since it's asking for the distance in the construction zone, we want to use the 25 hundredths of an hour, 0.25. So we're not multiplying it by the 15 minutes. We're multiplying it by 0.25 hours because he drove per hour. So we need to use the 0.25 because that's talking hours. So we need to take the 50 and multiply it, by 0.25, which gives us 12.5. So he can go 12.5 miles. All right, all together. So again, one thing I want to reiterate with these word problems is it's very important to identify your rate, your time, and your distance in each problem that you do so that you know where to substitute it in your equation when you're talking about the speed. All right, this last page, I'm just going to have you do a few of these on your own down here at the bottom. So I'm not going to have you do a lot, just a couple. So let's see. When you're reading these problems, one of the rules that I'm saying that you have to do is you have to, the underlined parts, you need to identify whether it's the D, the R, or the T. So make sure you do that. Just like it shows up here. And for every one of these that I assign, I also want you to use the formula and substitute them in just like I did back here. Okay, so I'm going to have you do number 1 down here. This is where you're going to show your work. Okay, you may use a calculator to help you. I'm going to have you do number 2 down here. Also, you may use a calculator to help you. And I'm going to have you do, let's see, how about number 4? So 3 questions, and you may use your calculator to help you. But again, before you start doing any of these questions, you need to identify which is the distance, the rate, and the time in each of these in the underlined parts in the questions. All right, thanks for watching.